Imagine, let's say, if you're going, let's say, on a cycle, right? Let's say you're bicycling, right? Let me just draw the bicycle. Let's say your bicycle, let's say, okay, and this is the seat over here, and this is your handle, right? So let's say this is person named Ali, right? Ali is going on a road, right? He's driving his, he's cycling his basically bicycle, and it's a sunny, bright day, right? And he loves to cycle. So imagine now, let's say there is a bee, right? A small bee. Have you ever faced, let's say, ever you are bicycling, or let's say if you are going on a road, have you been basically, have you basically contacted, or let's say made a contact with the bee? किसी का हुआ है कि bee आके it hit on your forehead or any part of your face whenever you're bicycling or going on a car or let's say going on a bike, ठीक है? Raise your hand who has encountered this scenario. Okay, Mashal has encountered this scenario. And also, right? So imagine you, okay, so what is the, let's take this, right? The mass of a bee would be around, let's say, 0.01 kg, right? It's pretty small. And your mass of Ali is, let's say, 60 kg, right? So imagine this, that's such a small mass when it hits your forehead or any part of your face, right? You feel so much pain, right? So Mashal, can you define, can you explain your experience? What happened and how was your basically reaction, right? Can you define your experience in some, yeah.
I can remember actually that when I was riding bicycle in early morning and a bee out of nowhere came and it just hit my forehead. And I felt like something has been hit on my forehead but I didn't quite know what it was. So it felt a little bit pain there was there and just that's it.
Okay, good. What about Ryan? How was your experience? I have experienced this myself also, right? Just a small beam and it hits your forehead or your face. It basically strikes pretty sharply on your forehead. Okay? And you just imagine it, it has such a small mass. How can it strike and how can it cause such a huge impact on your forehead, right? Ryan, how was the experience?
So yeah, it was like that.
Okay, yeah. Okay, so because what is happening, right? Because it is the bee was moving with the velocity also, right? It was moving, let's say, with a velocity of 50 meter per second. That's a huge velocity, right? So we're gonna relate mass and velocity into a quantity, right? So it will make sense now. Okay, why did it pinch you in your face, right? When it strike your forehead or any part of your face. So that basically phenomena will be explained using momentum, right? Up starting formally, what is momentum? So momentum is as follows, right? So momentum is used. Let me just skim the content and then we will do example, right? So momentum is a useful quantity, right? It's pretty useful. So when bodies are basically colliding or exploding, right? So in this particular example, the B is colliding with the face of Ali, right? So there is a collision, right? There is a collision. So this basically includes, basically this introduces the phenomenon of momentum. So what is momentum? It is pretty simple. It is defined as the mass of the body multiplied by with the velocity, right? Right. So this is the formula of momentum, and this symbol is called. This is a foreign symbol, right? This is a Greek symbol. It's a Greek symbol, right? Which is basically called rho. Okay, and m is over here. What m is your mass, right? Mass is in kg, and v is your velocity. Okay, that is your velocity. That is in meter per second, right? So, and this is the following formula, right? If you have a question in your theory exam, let's say it says, okay, let's say what is momentum, right? So you can simply use this definition in your blue box to answer it, right? Momentum is basically mass times velocity. That's it. That is your definition of momentum. And how do you define this formally? Okay, using a formula that is as follows, right? Let's see how do we have this, right? How do we have this SI unit, right? What is an SI unit of a quantity? Can you even explain what is meant by SI unit? what is meant by SI unit of a quantity? We had done this in the first chapter, right? We defined SI units definition. What is it? Can you
So
explain?
SI unit is a standard unit given to every quantity. For example, for mass we have kg, and
Mhm.
for
Good.
speed we have meters, and like that.
Good. So SI stands for System de International Unit System, right? It stands for System de International System de International Unit System, right? So it basically defines some units of the quantities which are standard throughout the entire world, right? Like mass is measured in kilograms throughout the world, velocity is measured in meter per second throughout the world, right? So let's find out the SI unit, right? What is the SI unit of this quantity momentum, right? Let's find out the SI unit. Let's find the SI unit of momentum. So what is the formula of momentum? Can anyone tell me the formula? Rho equals to what?
Mass multiplied by velocity.
Right? Mass times velocity. And let me just write down the terms. M stands for mass, right? M is mass that is measured in kilograms. And your V is your velocity. If anyone has a question, please raise your hand and ask, right? Don't stay quiet or don't feel shy. Ke it is a stupid question. No question is stupid, right? Okay. So if you have a question, ask. So let's find out the SI unit of momentum over here. So m is mass, so kilogram comes over here, and velocity is meter per second. So we have one representation of the unit of density. Oh, sorry, not density, momentum. That is kilogram meter per second, right? Okay. Now, if you recall, now let me just shape it into another form. Okay. So momentum has a base unit of the SI unit of kilogram meter per second. But if you recall your theory, it is also measured in Newton second, right? It is also measured in Newton second. तो अब ये कैसे आया? Let's check it out. If you recall your force का formula, what is force का formula from Newton's second law? That F is equals to ma, right? And what if I basically replace this? So what is basically the meaning of ma? M is kilogram and acceleration is meter per second square, right? So this is corresponding to Newton. So we have learned this in chapter of forces. How do we define, how do we identify, how do we derive the unit of force, right? So how can I shape this formula into this form? How can I shape this formula? Let me reiterate my point. I'm asking, okay, how can I shape this formula into this form? What change do I need to do to get into this particular format? If I do this, if I multiply and divide with second, so kilogram meter per second, multiply and divide by second, right? So what is second upon second? It is one, right? So it doesn't change this basic formula, right? But it gives me something interesting. That is as follows: that density equals to kilogram meter per second square into second, right? So what is this particular thing? It is it is what? It's Newton, right? So therefore, I can also write down the SI unit of momentum as Newton second, right? So we usually use this particular SI unit for the momentum, and that's how you derive it. If it is clear, give me a thumbs up, please. If this derivation is clear, give me a thumbs up. It is clear to Mashal, Ryan. What about it's clear to Hamza? What about Maeve? Okay, it's clear to Maeve also. That's good, right? So these are important techniques, right? I have also shown you how do we derive it. Okay? So we have learned the introduction. Okay, what is momentum? We have learned how do we define it formally in words. We have learned how do we define it in basically using a formula, right? So I'm gonna give you a hint, a trick, right? Let's say if you forget the definition, just remember, just basically recall the formula, right? The formula is this. So if you let's say forget the definition of a quantity, just recall its formula and just write down the formula in terms of word, right? So it is pretty simple, right? It's mass times velocity, right? If you let's say forget the exact terms of a definition, you can just write down the formula in words. Okay? That will give you 1 mark. Okay, so then we have conservation of momentum, right? Like we are living in universe, right? We are living in solar system. That is, we are living in Milky Way galaxy, and inside the Milky Way galaxy, we have a solar system, right? So if you recall anything, right? Atom, from atoms to universe, right? Everything is conserved, right? So in physics, we always maintain conservation, right? Whether it is conservation of charge, conservation of momentum, conservation of mass, okay? So we always want every quantity in the universe to be conserved, right? Up, keeping that in mind, can you explain, give me an idea, what is conservation of momentum? A rough estimate, a rough idea. I just want to have your point of view, right? Whatever you understand till now. Raise your hand and just share your views. I want you guys to participate, please. That's how I can realize कि how should I plan my lecture, right?
सर अगर दो बॉडीज कोलाइड होंगी तो
Okay.
इन पे उनका जो मोमेंटम है टोटल मोमेंटम सेम होगा कांस्टेंट होगा
Mhm.
और कोई एक्सटर्नल फोर्स नहीं होगी स्टोन के ऊपर
Okay, good. Anyone else? What about Ryan? What are your views for conservation of momentum? Yes, Ryan. Ryan, give me a guess. Is Ryan here or is Ryan having a cup of coffee or chai and just enjoying the class?
Sir, I'm here.
Just give me a hint or just guess what is conservation of momentum.
Sir, when two bodies act on each other
Mm-hmm.
or in any way,
Yeah.
uh, the total momentum remains constant. It stays the same
Okay.
if no external forces act on them.
Okay. So, do you agree with this statement? Should it stay conserved or no?
It should.
It should, right? Because लिखा वैसे ही written over here. It should, right? We are studying this chapter. Okay, it should, right? Let me just give you an example, right? Okay. Let's imagine we have a very reckless driver, right? We have a reckless driver. This is your road, and this is your, let's say, a wall, right? This is your wall. Let me just draw two cars. That's more better. This is car A. We have two reckless drivers. This is, let's say, the Toyota of 1999, right? And this is, let's say, another Toyota, right? But I can draw only Toyotas. That's my skill, right? I can give you vintage vibes. Okay, so this is car A approaching over here, and this is car B. Okay, this is before collision, before they collided, right? What happened? And then let me draw case number two. Now we have a case number two. That is, ये क्या हो गया? There is a buffer, right? There is a case number two that is after collision, right? Okay, so now what happened? The two cars stuck to each other, right? They stuck to each other. Let me just draw if they are pretty broken. They are stuck to each side. This is again car A. This is car B, right? So now let me give you some values, right? Let's say the mass of this car is the car A. The mass of car A is, let's say, 50 kg. Let's imagine 50 kg, right? Not 50 kg. It should be 500 kg. And the mass of car B is, again, it's the same model. It's 500 kg, right? And this velocity of the car A is moving at a velocity of, let's say, 10 meter per second, right? and this velocity of the car V is again 10 meter per second, right? Now, after collision, what happened? The masses are same, right? The masses are same again, that is 500 kg of mass car A, and the car B has also a mass of 500 kg. But they stuck and they basically stop, right? The final velocity is basically 0 meter per second for car A also. And for car B, the final velocity is again 0 meter per second, right? So these are two cases which I want you to see. Okay, now, acha, just recall your mathematics class, right? This is your positive x, right? And this is your negative x, right? So we're gonna take this direction as positive, okay? And you're gonna take this direction as negative, right? Because velocity is vector quantity. अच्छा मुझे बताएं कि इस velocity vector और scalar, is velocity vector or
Vector.
scalar? Why?
That has a direction.
So it has basically magnitude. Let me just write down short form. It has also direction, right? So direction के लिए we are basically specifying our assumption, right? So this direction is going to be positive and this direction is going to be negative, right? So if you see this car is moving in this direction, right? So it has positive velocity, that is VA. This car is going in left direction, that is going to have a negative velocity, that is going to be negative VA, right? Now, let's do some calculations, right? So let's try to understand what is conservation of momentum. What are we talking about, right? It's a collision, right? So car, they were moving before, and then after collision, they stuck to each other, right? They stopped. Okay, so now do let's right. Okay, so let me insert a blank slide again. Blank slide is okay. So let me just do some calculation, right? This is before collision. So what does conservation of collision? इसको हम बाद में करते हैं, ठीक है? Let's find the momentum before collision, right? Let's find the momentum before collision, right? Before collision. ठीक है जी. So it's going to be basically sum of both of them, right? Because this body has, what is the momentum of car A before collision? That is going to be the mass of car A times the velocity of car A, right? And what is going to be momentum of car B? Because momentum formula क्या है? The momentum formula is mass times velocity, right? So we are just simply multiplying the individual masses and the individual velocities. What about the momentum of car B? That is going to be the mass of car B times the velocity of car B. ठीक है? So now I want to find the total momentum before collision. Okay. So for total momentum before collision, I'm going to add momentum A plus momentum B. Right. So that is going to give me the total momentum before collision. That is momentum of car A plus momentum of car B. Right. So what equation do I get? That is mass of A times velocity of A plus mass of car B times velocity of car B. So we are giving some values over here. That is mass of car A is 500 kg. The velocity of car A at this point is 10 meter per second, right? And we have also seen the direction of velocity is going to be positive. The VA is going to be positive 10 meter per second, right? Now, similarly, if you see this, the velocity of car V is moving in left direction. So it has a negative velocity, right? So therefore, you can include a sign of negative with this velocity, right? Because velocity is vector quantity. It will have direction, magnitude, and SI unit, right? So just put in the values. The mass A is basically 500. Mass A is 500 kg. The velocity of A is plus 10 meter per second. Again, the mass of B is 500 kg. The velocity of B is going to be basically is negative 10 meter per second. Right? You have all the values. Just substitute the values in the equation to get your answer, right? So it's going to be 500 times plus 10 plus 500 times negative 10, right? So what is your answer coming out to be? Momentum before collision. So BC stands for before collision. What is the answer coming out, guys? What is the answer of momentum before collision? What is 500 times 10? It's 5,000. Okay. And what is 500 times negative 10? It's negative 5,000, right? So it's coming out to be 0 Newton second, right? So the answer of momentum before collision is coming out to be, the total momentum before collision coming out to be 0 Newton second. So according to, now I'm going to get back to conservation of momentum afterwards. Let's find the momentum after collision, right? So how will I find momentum of car A again? Is going to be mass of A times velocity of A, right? What about momentum of car B? Again, mass of car B times velocity of car B, right? And how will I find the total momentum after collision? I'm going to add these 2 points together, right? So now let me just do this. So let's talk about now before after collision, right? So what is the equation? Basically, I'm going to represent this at as AF. Okay? Sorry, AC. AC is after collision. Just to save my time. So momentum after collision is going to be momentum of car A after collision plus momentum of car B after collision, right? So this comes out to be what? Mass of A times V of A, final speed of car A time plus mass of car B times the final speed of car B. Okay, जी? So you know the masses and you know the velocity. So MA is 500 kg. The final velocity of car A is 0. So you don't care about the sign right now. The mass of B is again 500 kg and your final velocity of car B is again 0 meter per second. Right? Because they both stuck to each other, they both stop after collision. Right? Just put in the values to get your answer. So after collision is going to be what? 500 times 0 plus 500 times 0. So therefore, the after collision momentum is also coming out to be what? 0 Newton second. Right? Now let me just get to your conservation of momentum. Okay, what is conservation of momentum law? What is conservation of momentum? So it says the following, right? That is the sum of momentum before collision is equals to sum of momentum after collision. Right? So that is the law of conservation of momentum, right? This symbol means sum, right? This symbol means sum. It stands for sigma. इसका नाम है sigma. It's a Greek term again, right? So if I write this down in terms of words, that says the sum of momentum before collision is always equals to sum of momentum after collision, right? So what is the assumption over here? We're assuming that there is no friction, right? There are no losses, right, over here. So we are assuming what? We are assuming that there is no friction, right? Okay, so we have no losses of momentum, right? So momentum is only transferring between the cars. Okay, it is not going to surrounding, right? There is no loss. Okay, so now let me check this same thing, right? So momentum of before collision, that is BC, should be equals to momentum after collision, right? So can anyone tell me what was the momentum before collision in our example, which we did it right now? It's 0, right? So 0 is coming out to be after collision is 0, right? So therefore, हमारा जो conservation law है, it passes and it says कि this is correct, right? That is, it is saying कि your momentum is conserved, right? The momentum is conserved. Okay, so I believe it is clear. I went pretty slowly and I tried to show all the steps in between, right? So if it is clear, if the example is clear, give me a raise of hand. Just give me a thumbs up. Yeah, if it is clear. It's clear to Mashal, it's not clear to Hamza, not clear to, it's clear to me, if good. Hamza will clear it, okay? So that is your summary of conservation of momentum. I hope it makes sense, right? I try to include values so that it makes more sense, right? So this is summarized over here in this slide. Okay, conservation of momentum. So what does it say? Let me just try to skim it out. So when two or more bodies acts on one another or collide, right? The total momentum of the bodies remains constant, right? Provided there are no external forces, friction वगैरह नहीं है, कुछ losses नहीं हो रहे. So if a definition comes in your exam, what is principle of conservation momentum? So you should write this down, right? That says that when two bodies collide with each other, right? total momentum of the bodies remain constant, provided that there are no external forces, right? So that should give you the marks of your question. Okay, what is principle of conservation of momentum, right? I hope it makes sense. Now we have also done an example so that I can test you guys. So now everyone take out your copies and a pencil and a calculator and solve this question. So you have two basically masses over here. You have mass A, that is a trolley, and then you have another trolley, okay, a truck, okay. Let's say they are given a truck of mass 60, and you have basically a truck of mass 30, right? So this is mass A, let's say. Okay, guys, am I audible?
Yes. Yes.
Okay, good. So I guess let me wait for 1 more minute till everyone joins. Okay, Ji, so everyone is here. The rest can join in midway. So now what you have over here is that you have two trolleys over here. Of course, the masses भी दी हुई हैं. Let's say this is mass A, this is mass B. The basically the initial velocity of object A is 3 meters per second, and the initial speed is basically of B is 0, right? Because it is at rest. Now this is basically before collision, right? This is before collision. Now after collision, again the masses are same, right? This is mass A, this is mass B. What happens? This is after collision. The bodies stick together and they start to move in this direction together, right? Okay, you want to find this velocity v, right? So you want to use basically conservation of momentum law to find out the value of v, right? And what does it say? It says the following. Okay, it tells you the following thing, that is the sum of momentum before collision is equals to the sum of momentum after collision, right?